All right, folks, it's back in action here. In this video, we're going to start to look at some of the basics of simplifying identities. And identities are simply problems that need to be simplified so that you can work with them in an easier fashion. That's really all it comes down to. There are some main tools, so they're often not as confusing as they seem. So we're going to go through two of the main tools in this video. We're going to talk about factoring, or foiling, that's basically the same, and working with the Pythagorean identities. So down here you can see we're on the back of the yellow foldable, so if you're a student in my class, you should have this foldable, flip it to the back, otherwise just follow along. You can see I've got the three Pythagorean identities down here, and of course you do need to know these. There's a variety of ways to get these memorized, but you do need to have these memorized. I do like to personally write them down for myself just because I tend to be a little more visual. So I'm going to reference these. I'm going to do three problems here that will use these a little bit, and then on the other side of the foldable I have a whole bunch of practice that you can do rearranging these. So taking a look, let's say here at this first problem, what we would want to recognize here is that this problem could be factored. Now, if you don't see it right away, you could think of this like this. Now, I wouldn't suggest always rewriting it like this, but if we think of the sine as an x and the cosine as a y, this really could be imagined as like an x minus an xy squared. And if it was in terms of the simple variables, you would easily be able to see that you could factor out an x. So what we're going to do is we're going to look at this and factor out a sine. So we're going to factor out this sine theta. Very common error is to kind of lose those thetas, to forget to write the angle. Don't forget to do that. Well, we're going to factor out that sine theta, and that's going to leave us with a 1 minus cosine squared theta. Now, as soon as you start to see things that are added and subtracted, in particular, something may be squared, you're looking for ones, you're looking for addition, subtraction, that's really kind of your clue that you probably have a Pythagorean identity coming along. So since I've got this 1 and the cosine squared, I'm going to come down here and I'm going to look at this Pythagorean identity. And sure enough, if I have this 1, and if I imagine I take this cosine squared and I subtract it to the other side, then this side of the equation would be a 1 minus cosine squared theta, and then the other side would be sine squared theta. That means that this piece right here could be replaced with a sine squared theta. And then, of course, I still have the original sine theta. And when I simplify that and just multiply those out, I end up with sine cubed theta. Remember, the cube comes before the theta, not after the theta. So on our next one here, what we're going to notice is that the numerator could factor, okay? And what we're kind of visualizing here is we're visualizing like an x squared plus a 2x minus a 3, where our x's are cosecants. So we're going to write this as a cosecant theta plus a 3 and a cosecant theta, and then minus a 1. So that's going to factor the numerator. The denominator could factor as a difference of squares, so we'll have a cosecant theta minus 1 and a cosecant theta plus 1. And now we can see that sure enough, these would cancel. This one doesn't clean up a ton. This is all that we're going to be able to do. So we'll write our final answer is a cosecant theta plus 3 over a cosecant theta plus 1. And that would be our final answer. And that's all it would simplify to, and that's okay. On the next one, when I look at this one, I don't have any, I see things added and subtracted, but I don't see anything squared and I don't see any ones. So Pythagorean identities aren't going to be useful, but I could FOIL this out. So instead of factoring like we just did, we could FOIL this one. So that's what I'm going to go ahead and do. So I'm going to FOIL this out. So I'll get my cosecant squared theta. The squared comes before the theta. Then I'm going to have a cosecant theta and a cotangent theta, but notice that we really have a difference of squares here. So that's the first one. This is going to give me a positive cosecant theta, cotangent theta. This is going to give me a negative cosecant theta, cotangent theta. So they're actually going to cancel each other out. So I'm not going to actually bother to write them out. Then I'm going to distribute the last one, and that'll give me a minus cotangent squared theta. And now I've got some squared terms that are being added and subtracted. That's my clue that I might be able to come down here and use an identity. So sure enough, I find a Pythagorean identity that uses cosecant and cotangent right here. And I can see that it's cosecant minus cotangent is what I need. So here's my cosecant. I'm going to imagine this cotangent squared being subtracted over. That would make the right-hand side match what I have here, which means that leaves me with just my positive 1. So this whole thing just replaces to a nice 1. And then I'm all done. Okay, now if you flip to the other side, I've got a whole bunch other substitutions that we could do. Again, just really practicing with those Pythagorean identities, rearranging those. So the first one, what we're going to think about is we would have a sine squared plus cosine squared is 1. So we're going to have our 1 minus our cosine squared. So that's actually the one that we did on the other side. So this would simplify to a sine squared theta. The next one would be a sine squared minus 1. So if I'm visualizing sine squared theta plus cosine squared theta equals 1, and if I have a sine squared theta minus 1, these two are actually switching places. The 1 comes over here, the cosine comes over here, so this is actually going to simplify to a negative cosine squared theta. You've got to be careful with those negatives. Now, on our next one here, notice that our angle measures are not the same. So before we move on, we do need to make those angle measures the same. We notice that they're different, but they are also complementary. So I'm going to use my complementary cofunctions here. I'm going to switch my 80 degrees to my 10 degrees, which means I'm going to switch my cosecant to its cofunction, which would just be secant. So I'll have secant squared 10 minus tangent squared 10, and now that is going to match one of my Pythagorean identities, and if I rearrange that one, that's going to give me a nice 1. On the next one, I've got my tangent squared theta and my secant squared theta, and if you're having a hard time doing these without the identities here, I'll go ahead and I'll write those out for you again. Tangent squared theta plus 1 equals secant squared theta, and I'll go ahead and write the cotangent squared theta plus 1 equals a cosecant squared, oops, got ahead of myself there. Okay, so on my tangent squared theta minus my secant, so again, this is similar to what we did here on number 2. The 1 and the secant are going to switch places there, so that means that I'm going to end up with a negative 1 here. For my cotangent and my cosecant, I've got my cotangent and my cosecant. Same exact idea. These two are going to move places. So the left side matches what I have here. The right side is what it would become for its nice substitution. And then my 1 minus my cosecant squared, that's going to be a 1 and a minus, so I need to move the cosecant over here. So I would need to mentally move the cotangent to the other side. So that's going to give me a negative cotangent squared theta. All right, so this is one of our tools, and then there are 2 more videos that will cover the other tools that are in this foldable.